Now in this video, we're going to be looking at LangGraph nodes. LangGraph nodes. Now, if you've been watching other videos in this LangGraph fundamental series, we've been using nodes a lot. There's no how you can build a graph without nodes. Nodes are basically the core of graphs. So you're definitely already familiar with nodes, but in this video, we're going to be taking a deep dive or a deeper dive into nodes. Now, nodes are primarily the action takers in a LangGraph graph. So let's just say we have a graph like this. So let's say this is our graph, and our graph is going to consist of one or more nodes, and these are basically the processing units within our graph. This is where actions take place. If you need to call a file, or if you need to read a file, this is where you do it. If you need to call an API, this is where you do it. If you need to call an LLM, this is where you do it. Every single processing you need to do, this is where you do it. So just think of nodes as basically functions. They are functions, and what you basically do is that you call them in sequence or in parallel based on the kind of workflow that you want to perform. But every single processing in a LangGraph graph is done in nodes. And as we've seen in other videos, nodes are connected with edges. You will see later that we can even have some nodes that are not connected with any edge, but you can just navigate them dynamically. But that's for another video. But nodes are basically the action takers in LangGraph. That's where you do all your processing. Every single action you want to take, every single tool you want to use, you do it in a node. And node represents, they also represent steps in a particular workflow. They represent steps in a particular workflow. So let's say you want to draft an email, or rather you want to send an email. So first, you probably have a node that takes input and processes it. So once that node is done, it then routes to another node, and the node composes the email. That other node composes the email. Then the next node sends the email. So that's how you compose nodes. So you put your unit actions, the unit actions of your workflow, in nodes, and you connect them with edges in the sequence they are to follow. Or if they are to operate in parallel, you also make them run in parallel. So that's basically what nodes are. And in the background, LangGraph converts nodes to runnable lambdas. So if you have gone through the LangChain series, our LangChain series, you will definitely know what runnable lambdas are. And runnables being the core data type, so to speak, in LangChain. And also, if you think of nodes in terms of runnables are a unit of work. Yeah, a unit of work. And they take an input, they return an output. They take an input and return an output. Now, typically for nodes, they take in state and they return an update to state. We've already looked at state in LangGraph. So nodes basically take state, they read it to do their processing, and they also return an update to state. And if they have no update, they can simply just return the entire state and everything just remains as it is. But in this video, we're going to also be seeing some other things that nodes can take in. But basically, nodes behind the scenes are converted to runnable lambdas, so it makes them possess all the features of runnable lambdas, the async features, the functions you called, invoke, batch, stream. So all those properties, nodes inherit them naturally. So that's nodes in LangGraph. And because they're runnable lambdas, they also take advantage of all the tracing capabilities that come with the runnable architecture. So you can use, if you plug in something like Langsmith, it's just native to LangGraph to get you your tracing data and to also perform other observability functions for your LangGraph agents. So, like I said, nodes take more than state, but let's just look at the three things that nodes take. So, first, they take state. They take your graph state. So when you define a node, and to reiterate, nodes are basically functions. Nodes are functions. So if you're using the Python SDK, nodes are Python functions. If you're using the JavaScript SDK, nodes are JavaScript functions. So nodes are basically functions. And they take in state. That is the default argument that you find in every node. So if we say if we define a node, let's call it node A. We say we define a node A. That node A can take in state. Let me move this down. Yeah, so that we can have this here. So we don't have to squeeze it to the side. So let's say we define a node A. Our node can take a state argument which is of the type of our state schema. That's the state schema that we defined. So let's say we called it state schema. So it will take in states, and it will be of the type of the state schema that we defined. Now that's the default thing that every single node takes, and is always the first argument. It's always the first argument to your node. And when you inside your node, you can do any type of processing you want. You can do any type of processing you want. You can access state variables by, let me get out of here. You can access state variables by saying state and key. So whatever key your state variable is, you can use it to access the state value in inside your node. And you can use that for any of the processing, any sort of processing that you want to do inside the node. So this is basically how you read state. And if you want to return, if you want to update state, you simply return your update, use the key of the state that you want to update, and a new value that you want to update the key in state with. So these are your update state, and you don't need to return the entire state. You just need to return a dictionary of all the properties that you want to update. So key, let's say I want to update key, and I want to also update key 2. So I'll say key 2, and that will be, let's say, new value 2. So you simply just return only the properties that you want to update. That's how you work with state in your nodes. And everything within your node is the same way you work with any Python function. Just do your processing the same way you're going to work in any Python function. But you know that whenever you want to write your return statement in the Python function, you are returning an update to the state, and it would be a dictionary of the properties and states that you want to update. Another argument you can have in your LangGraph node is config. Yeah, you can have a configuration. You can send in a configuration into your LangGraph node, and that will be of the type runnable config. Runnable config. So you can send in a runnable config into your LangGraph node, and you can use it to store configuration parameters. Even though I checked the new documentation that is coming out for LangGraph, that's the 1.0 for the version 1.0, and they are beginning to favor the next thing we're going to look at that you can have in your in your nodes. That's the context schema, which we're going to be looking at next. They're beginning to favor it for configuration over config, at least for runtime configuration. But you can also use runnable config to pass in configuration values that you can use for each run of your LangGraph graphs. So you can take in config. Another thing you can take in is context schema. Or let's just say context. It's context. It's time to get this guy and move it in here. So I'm going to replace runnable config with runtime schema. So you can also pass in your runtime schema, which I said it's the preferred way now to pass configuration to your LangGraph nodes. And basically what are these configurations? It's just values that you want to remain static within each run of your node. They are not state variables that change. They are not going to change. They're going to remain persistent through each run. So you can set defaults for them, and you can also override them when you want to invoke your graph. You can override some of them when you want to invoke your graph. So the context schema is, to me, kind of cleaner than runnable config, even though runnable config is still more elaborate, coming from the whole LangChain framework structure. But runtime context is much cleaner to work with. So for runtime, you basically pass in an annotated runtime. You annotate it with the context of your runtime. Let's say runtime context. So we're going to be looking at this much later. It has its own video, so we're going to be looking at it much better later. But basically what you do is you use the runtime class and you annotate it with the runtime context schema. So just like you define your state schema, you also define a runtime context schema and use it to annotate the runtime class. And once you have it in, sorry, this is runtime. It's a runtime, not this is runtime, not context schema. Context schema is for when you want to invoke it. So this is runtime, not context schema. This is runtime, not context schema. And whenever you want to access your runtime, let's say you store, let's say database URL there, you say DB URL, you simply access it as runtime dot context dot db URL. So if you have defined a db URL in your context schema, this is how you access it. So I can say URL, let's say MySQL URL. MySQL URL equals runtime context db URL. So that's how you access. Let me lift this up. That's how you access your context schema. So that's how you access your context properties. So those are the three arguments that your nodes can take. State, which is the de facto argument for your nodes. Then we have config, which you can use to pass in a runnable config object, and also runtime context, which we're going to be looking at. We're going to be looking at the three of them basically. So now let us, before we go into Visual Studio Code, let us look at some default nodes that come with LangGraph. Now, the first default node is the start node. There's a default start node that comes with LangGraph, and the main purpose of the start node is for you to define the starting point for your graph. Yeah, it defines the starting point for your graph. So you want to say, this is the first node to call. So let's say you have a node A. You say from start to node A. So it marks node A as the entry point for your application. That's why most of the initial nodes are for collecting input from the user. But yeah, this is how you point to the node that you want to start with. And you can also point to a bunch of nodes in parallel. But the start node is for you to define the node that is going to be the entry point, the node or nodes that are going to be the entry point for your application. Then we also have the end node. And this is your termination node. This is where you say graph run complete. So as you build your graph, let's say you go from this node, then you go to that node, go to this node. Then when you get to this node, you want to terminate your operations. So what you basically do is go from this node to end. So let's put start here. Let's say start. So for start, you go from start to this node. So you say start at this node. Then this node does its processing. It updates the state. Then the LangGraph moves to the next node, which is connected to this first node with an edge. It moves to this node. This node does its processing. Then it returns some updates to state, or just returns the state. Then it comes to this node. It is done. The email is sent. We got the user input from here. We composed the email here, and we sent the email here. So once we're done sending the email, we end it. We end the process. So that is what these default nodes do. Start node helps you to point at the very first node that should be run, and end node helps you to terminate the operation of the graph. Now, for every node you create, for every Python function or JavaScript function that you create as a node, you actually have to add it to your graph. So when you set up your graph, something like builder, all caps, nope. You say builder equals state graph, and you pass in your graph state, or let's just say state. So you pass in your state to state graph, so you have your graph builder. Now inside your graph builder, once you have defined your node, you have to add it to this graph builder. You have to add it to this graph. So you say builder, and you call the add node function. The add node function, that's the function that you use to add nodes to your graph. So you say add node, and then you give it the name of your node and the function. You give it the name of your node and the Python or JavaScript function. So let's say we call this my node. So you give it the name of your node, that's the name you want to call your node, and you also pass in the name of the function. You just pass in the name of the function. So if the function is, let's say, send email, if the function is send email, you come here and say send email. Send email. Now, it is best practice to always give your nodes the name, a name rather, that describes what they do. A name that describes what they do. So if your node sends mail, call it send mail. If your node drafts mail, call it draft mail. And sometimes also a lot of people just try to match it with the name of the function. And that's why in LangGraph, if you just pass in the function, let's say you don't pass in the name, if you just pass in the function, it will automatically give the node the name of the function. So if I define a sendMail function that is to be my node, and I pass it to this addNode function directly, sendMail is going to be automatically be the name of my node. It's going to be automatically be the name of my node. So that's what I will use to reference it when I'm connecting edges or when I'm doing anything with the node, or using it in the command feature that we're going to be looking at later. So yeah, this is how you we've talked about what nodes are, how you build them, the arguments they take, how you add them to your graph. Now let us go into VS Code and actually see LangGraph nodes in action. So now that we understand what nodes are and their purpose in LangGraph, let us write some node code. So here in VS Code, first I'm going to create a new file. I'm just going to call it nodes.py. Or let's just say nodesdemo.py. Because you start adding demo to always suffix all my files with demo now. So nodes demo. And what we're going to be doing in this demo is that we're going to be creating 3 nodes. A graph that has 3 nodes. Now, one node is going to take the state, just the state of the graph. Another node is going to take state and a runnable config for configuration. And our third node is going to take state also, but also take a runtime context. So we're going to see how we can work with all these arguments that our nodes can take. So to begin, first let us import our dependencies. I'm going to say from typing import, and then we're going to import from here. We're going to import typedict, and we're also going to import, I think just typedict from here. Then we'll say from LangGraph.graph, we import stateGraph, and we also import our default nodes, the start node and the end node. Start and end. That's good. Now the next thing we're going to do, we're going to define the state for our graph, our state schema for our graph. So say class, nope, all caps on, class, let's call it graph state, taking typedict, and we're just going to be defining 2 state variables, our input and our output. I'll call output results. So we're just going to have an input which will be of type string, and we have results which will also be string. So input, which is user input, and result, which is what we want to send back. Now the next thing we're going to do, we're also going to create our context schema. Yeah, we're going to be creating our context schema, and our context schema is going to just be a place where we're just going to store some static values that we can use within our graph. We don't want them to change. We just want to use it within our graph. But like I said, there's another video coming up on context schema, so you don't need to try and fully understand what this does from this video. So for that, I'm just going to create a class and call it context schema. This will also just, oh, I mistakenly opened another shell. Yeah, this will also just take in typedict. And what can we store here? Let's say user ID. Let's say user ID for our user, and that will be a string. So there we have it, our context schema, something simple. We don't need to go wild with that. Now, the next thing we're going to do, let me close out from this. Next thing we're going to do is to create our nodes. So first, I said we're going to create a node that only takes in state. A node that only takes in state. So I'm going to say define plain node. It's going to take the state argument, and we're going to pass in graph state for this, and that'll be good. Inside our node, we're simply going to just print executing plain node, so that we can know the node that we're in. Just going to put them dot here. So executing plain node, and let us return an update to the state. So I'm just going to return an update to results, and let's just greet and say hello. Let's assume that the input is going to be our name. So I'm going to say hello, and I'm going to say state input. So yeah, that's going to be our result from here. And that's everything we need to do here. That's everything we need to do here. Now the next node that we're going to create is the one that takes in a config, a runnable config. So I'm going to say define node with config. First we pass in our state, which is still going to be done the same way. Then we can pass in the config argument, and that config will be of the type runnable config. Runnable config. And because we have runnable config here, we need to import it. So say from lang chain call runnables import runnable config. Runnable config. So we have our runnable config, and thus we have a configuration. We have passed in a configuration to this node. Now for this also, I'm going to put a print statement and say executing node with config. Executing node with config. Now let us try and get one of our configuration properties, from the runnable config object. Now for that, I'm just going to get a thread ID. And say config.get from configurable. If you cannot access configurable, just give us an empty dictionary. And inside configurable, we need you to help us get a thread ID. So yeah, we can just print out the thread ID. Say print f, and just do this dub, yeah, and say accessed thread ID. Thread ID from config. I'll just pass in our thread ID here. And we can just return something back to state. Our results. That will be config successfully accessed. So this is a node with a config object, a runnable config. And we decided to use one of our configurable fields, which is thread ID. So we can set a thread ID on this upon invocation. So we have the node that takes a config. The third node that we're going to be creating is the node that is going to take in a context schema. So once we define that, I will say node with runtime. First to pass in the state, which will be graph state. I'm just going to copy that from here. Graph state. Good. Then we have runtime. That is the argument that takes in the runtime context. So right with runtime, and like I said, it will be a runtime object. And we need to get that runtime object from LangGraph. You can get that from LangGraph. From LangGraph.runtime import runtime. So from LangGraph runtime, we get runtime, and we need to annotate this with the schema that we define for our context. So I'm just going to grab that from here, context schema, and put it here. So that's good. Let's go into our node function. And what do we do inside here? First, let us print out our typical message that shows that we are executing this particular node. This will be node with runtime. And next, what do we do? Let's just get something from our runtime context. Let's just get that user ID. So for that, I'm just going to say user ID equals runtime.context.user ID. Runtime.context.user ID. Yeah, I think we need to access this as a, not this way. Sorry. Yeah, user ID. So runtime context user ID. So now that we have it as this, I'm just going to copy this print statement also and come down here. And I'll say access user ID from runtime, from the runtime. Yeah, from the runtime, I'm going to give this user ID. So that's good. Later on, I will see if I can access my user ID this way. But can I? I don't think so. Okay, so we have our 3 nodes. And now we can start building out our graph. So I'm just going to collapse this 3 for now so that I can get some room. At the start, I'm going to say builder equals state graph. And the first thing we'll pass to our state graph is our graph state. So let's get graph state. That's our graph state schema. Pass it in. Now, because this has a runtime, context, we also need to pass another argument, which is going to be context schema. Pass context schema, and that will be set to our context schema, which is schema we define for our context. So pass those 2 in. That's all good. Getting an error here. Oh, okay. Just set this equal. Yeah, sorry about that. So equal. So state schema, context schema. Yeah, we get context schema. And now we can start adding our nodes. So I'm going to say builder dot add node. And our first node is a plain node. So first I'm going to put in the name of the node and the function of the node. Name of the node and function of the node. And that's the same thing we're going to do for all our nodes. So I'm just going to copy this and duplicate it twice. So we have node with config and node with runtime. And now we have all our nodes complete. We've added all our nodes, but we need to connect them. We need to build a workflow with our nodes. And what we want to do is that we want to go to the plain node first. Then after the plain node, we want to go to the node with config. And after that, we want to go with the node with runtime. And after the node with runtime, after running that operation, we want to terminate the entire graph workflow. Now to do that, we need edges. So let us start adding edges. And going to say builder.add edge. And like I said, to tell LangGraph the node we want to start from, you have to use the start node. So the start node will be able to point at any of your defined nodes and say, this is the node that is going to serve as the entry point. So we start with start node and we say, go from start node to plain node. From start node to plain node. And after that, we want to go from plain node to our node with config. Then from our node with config, we would like to go to our node with runtime. And after we're done in our node with runtime, we want to terminate the operation. So we go to our end node. That's our workflow. Start plain node to node with config to node with runtime, then node with runtime, terminate. Awesome. Now we can simply come down here and compile. So I'm going to say graph equals builder.compile. Awesome. And now we can run our graph. Just put a comment here and say run graph. Run the graph. And for the state, or rather, we need to define an initial state. So I'm going to say initial state. And all we're going to do here is just pass in an input. And because we simply want to say hello here, I'm just going to pass in my name. Pass in my name as the input. And this is going to be passed in as the input argument for our invoke function. But remember, our graph also takes in a configurable or a runnable config for configuration, and also takes in a runtime context. So we need to define values for that too, so that we can pass it into our invoke function. Let us do that. First, let us start with the configuration. I'm going to say run config. And we're just simply going to use a dictionary where we set a configurable and set that to a thread ID. And this thread ID, I'm just going to make it up and say ABC123. But this is a very good way for you to track your node operations. But here I'm just going to use a fictitious value. So we have that, and also we want to define a context. Let me say, let's say graph context. Yeah, graph context. And the only thing that we defined in our context schema is just user ID. So let's say you want to track a user ID for this, or you need user ID information within your graph workflows. You can also set it here. So I'm just going to say user ID. I'm going to set that to Optimus Prime. Optimus 103 Prime. Okay, so that's our graph context. And now let us invoke our graph. I'm going to say the final state equals graph.invoke. Graph.invoke, and here we'll pass in for our state. In some of the examples, we've just been dumping our state in directly into our invoke brackets, that's the parentheses. That's what you do when you just want to pass in state. You don't want to pass in any other argument. But when you want to pass in state and other arguments, you have to use the input argument to pass in your state. So we say input, and we pass in the initial state for this. Next, we want to pass in the config, which is going to be done with the config argument. So for this, we pass run config. And finally, for our context, we use the context argument, and we pass in graph context. That's good. So we have our input, we have our configuration, and we have our context. Now let us see what the final state looks like, and all the print statements we're going to get from running all our nodes. So I'm just going to say print final state. And just below that, we're going to print our final state variable. Final state. And now let us pull up our command line. Been typing a lot since. Pull up our command line. And we're just going to run Python. Oh, I'm not in my environment. Yeah. Let me activate my virtual environment. That will make everything blow up in my face if I don't. So bin activate. Good. So now we're in our virtual environment. And now I can run Python nodes demo. Python nodes demo.py. Let's run that. So we get executing plain node, executing node with config, and it was able to get our thread ID, which is ABC124. Then executing node with runtime, which is our third node, and it was able to access our user ID, which is Optimus 103 Prime. And the final state says the input is my name, which I passed in, and the results are config successfully accessed. Config successfully accessed. Now this is config successfully accessed because if we go, if we just go down, let's pull it down. We didn't return state from our runtime. I don't think we didn't do that. So it just automatically returned the state. It just automatically returned it. But normally we're supposed to return a state. You can just return the entire state. Yeah, you can just return the entire state if we don't want to change anything. So everything is still going to work fine if we do that. If I clear the screen, let's clear this. Let's run that once again. Everything still works fine. Everything still works fine. So we've been able to see how nodes work, how we can return updates to state, and if we don't want to change anything, it kind of returns it by default, but we cannot, or we can also be explicit about that and just return the entire state object, and everything is going to stay the same. And we've also seen how we can pass in state to our node, We've seen how we can pass in a configuration object with runnable config and also use runtime context, which I said we're going to be dedicating another video to.